I'm Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I'm going to discuss about the topic energy and power signals, which is studied in the Unit 1 classification of signals and systems in the subject signals and system by the second year in the third semester. Today I'm going to discuss about the signals, energy and power signals. Before that, I'm going to say about how the signal will be distributed and what are the information will be carried out in the signal, and the signal will be continuous or discrete signal will be there, and how the mathematical analysis will be useful for analyzing the signals, and how the energy and power factors are important for particular signals. Topic today I'm going to discuss about the difference by energy signal, power signal, difference between energy and power signal, and what are the examples related to that, and real time applications. First, in the empathy part, why we need this energy and power signals in the signal system. In the signal is nothing but it is carry the information from the sender to receive, and the system is nothing but it is processing our given information, processed and transmitted and analyzed. After that, it is received by the receiver side. In a signals and system, the energy and power is mainly used to analyze the communication system and to design the electronic circuits and to process the audio amplifier circuits and video signal together in that, and to improve the wireless communication factors. And in the defined part, understanding the energy signal, it is nothing but it is varies from 0 to infinity. The energy signal should not be 0 as well as should not be a infinity value. It should be ranges from 0 to infinity, where the energy signal, which is finite energy, will be there. There is no infinite energy in the signals, and its average power will be 0. So by considering these factors, we can calculate the energy by using the formula E, which is equal to minus infinity to infinity determinant of x of t whole square into dt. If the signal ends, by using this formula, when we calculate this, when the signal energy is 0 or infinity, and the signal is not a energy signal. And coming to the power signal which also varies from 0 to infinity, and it should not be a infinite value, and it should be a finite value. And the formula for calculating this power signal, which is P, which is equal to limit t tends to infinity integral minus t to t determinant of x of t whole square into dt square. By using this formula, we can calculate the power, and power when it is 0 and infinity, it is not a power signal. And coming to the ideate part of this energy and power signal, the examples related to that, when we are calculating the signal x of t is equal to e power minus t into u of t, the u of t, which is unit step signal, which is ranging from greater than or equal to 0, means the unit step signal is 1. For remaining cases, the unit step signal will be 0. When calculating the x of t signal, x of t for energy is varying from minus t to t. When it is given u of t in the sense it is having only positive energy and there is no negative energy. So it is varies from integral 0 to t x of t whole square into dt. So when calculating this energy, we can get which is finite energy, and average power will be 0. Therefore, the given energy is signal is energy signal. And we know that the pulse signal, which is rectangular pulse, which is energy finite, so it is energy signal. And calculating the x of t equal to a sine alpha t, where the signal is infinite and the power when we are calculating, which is finite. So the signal is power signal. When we calculating the square signal, the energy will be infinite and power will be finite. So given signal is power signal. And prototype part, where the comparison of energy and power signal, finite energy, infinite energy, 0 average power will be there, and finite energy power, non-periodic and periodic. An example of energy signal is pulse, and example of power signal is sine wave signal. Application related to energy and power signals. It is used in wireless communication, signal processing and image processing, and in the satellite communication, broadcasting and control and instrumentation, and biomedical signal analysis. For in biomedical, ECG and EEG energy signals are used for medical diagnosis. And coming to the summaries part of the energy and power signal, introduction, we have seen that why the signal is classified into energy and power signal, and the formula for energy signal E, which is equal to minus infinity to infinity x of t whole square into d square. Power signal P, which is equal to the limit t tends to infinity 1 by dt integral minus infinity to infinity x of t whole square into dt. And examples related to the energy and power signals, and the relation between the energy and power signal is seen. Thank you.